Hey there! Today we're going to do a little bit more an advanced problem. This problem involves a little bit of the colligative properties equation right here, and it also is going to take us from grams to moles and a few other things. So we're just kind of adding a few of the things that we know along with some of the new stuff. So it should be pretty interesting, and hopefully you enjoy this. All right, here's some information on the first page. I put each problem on its own page, just trying to keep things a little bit clearer and a little bit easier to keep track of. So here's all the information you need if you lose track of, like when water boils, the equations and such like that. All right, let's start with problem 1. Now I've set this up in a way that you have to find the givens and put them down, and also it will help you keep your flow, because that's what you need. You need a flow. You need to know where you're going to go. And so let's read the equation first. If you use 3.68 moles of sucrose, that's sugar, and this is the equation for sugar, and dissolve this into 2.5 kilograms of water, what will be the change in the freezing point of your solution? Assume that the Kf of water is 1.86 degrees Celsius per molality, and then remember, sugar is a molecule, so it's not an ionic compound, it's a molecule, so its I is 1. It doesn't break apart, it does not dissociate. So let's get things where they belong. Okay, so if we use this many moles of sugar, let's remember, go to text box, and you don't have to type, you can just copy paste, get the moles in the right spot, and the kilograms of water, put that in the right spot, right? And they want us to calculate the molality. Look at this right here. It doesn't tell us the molality at this point, but those are the two things that we need to know to figure out the molality. And so the equation for molality is little m equals moles of solute per kilograms of water or solvent, right? Let's plug those numbers in. So we're going to put in, I'm going to keep my phone alive here, hopefully, 3.68 moles for every 2.5 kilograms. That's set up real nice for us. So let's see what we can do with this here now. So we're going to take 3.68 and divide it by 2.5. And I'm getting 1 point. Let's call that 1.5. Hey, what the heck? Might as well. 1.5 little m. Now, if you keep it the regular number, that's fine. All right, I's. What's the I? I told you already, it's a molecule, so the I for a molecule is 1. The Kf is given to us because they're talking about freezing in water, so we use that number. If it wasn't water, we wouldn't use that number. If it wasn't freezing, we wouldn't use that number. But since it's water and freezing, we use that number. All right, let's sub the things we know into our equation. So the I is 1. Oh, it's not going to let me put it in. Okay, so come here. So I equals 1. Kf is negative 1.86. Right, we can copy paste those, right? That's what we have copy paste for. And I'm going to put that in parentheses to make it pretty. And the little m is 1.5. And again, in parentheses to make it pretty. Solving for delta t. Come on, calculator. Oh, you're still alive. I could keep that number in there. I guess I could put the 1.47 in there. 1.5, I won't though. 1.5 times 1.86, and then use the negative sign, not the, and then times 1 equals negative 2.79. And that's degrees Celsius. And if you're trying to figure out how to type degrees Celsius, it's a lowercase o that's put into superscript and then a capital C. All right, what's the actual temperature that it freezes at? Well, it's 0 minus negative 2.79, which just happens to be the same number. Okay, there you go. That's problem 1. Now, I want you to try problem 2, and it's very similar, except it's boiling, and everything's set up. Follow my example that we just did and see how you do. Hey, I'm back, and now we're going to do problem number 3. I skipped number 2 and left it for you, and now we're going to try number 3 and see what happens. All right, number 3, you dissolve 30 grams of potassium iodide, that's Ki, into 175 kilograms of water. What will be the change in the freezing point of your solution? Assume the Kf of water is negative 1.86. All right, so let's put our things where they belong. Grams. Well, our grams of potassium iodide go right here. Right now, the molar mass of potassium iodide, we're going to have to look up at the table here. Potassium is 39. Iodine is 127. So we have 39 plus 127 equals 166. So the molar mass, and the molar mass is that mass that we get from the periodic table. That's the mass of the compound, 166 grams. Number of moles that we have. Now we're going to find the number of moles. We're going to do a quick factor label, right? Oops, let's go to straight line to make that a little prettier. So let's go straight line here. Shapes, straight line. And so if I go grams to moles, and I'm just going to copy and paste here. So go back to your text box, copy. This was the given amount. I always start with the given right here. And then we're going to divide it by the molar mass. So we're getting grams and dividing it by grams. And that's the mass from the periodic table for the compound potassium iodide. And then we put 1 mole on top. Remember, it's always 1 mole. And that should do it for us. So if we take 30 divided by 166, that equals 0.18. So our number of moles is 0.18 kilograms of water. Kilograms of water is given to us, 1.75 kilograms of water. Molality. Trying to find our molality. Remember, our molality, little m equals moles over kilograms. So we just have to make sure we put our things in the right spot. We have our moles right here. Copy, put that in for moles. And we have our kilograms down here. Copy that, or type it, whichever you think is faster. Put that in for kilograms. And we should be ready to go. So we have moles in the calculator already, so I'm just going to divide by 1.75, and that's going to equal 1.03. And that's our molality. Number of ions. Look at that formula, Ki, one of each. That makes 2 ions. Our Kf is already given. So now we have to put these into the equation. So m, little m, molality, copy, goes in right here in the equation. I'm just going to type it right in the equation. Oops, no I'm not. I'm going to put it right below it. And I'll put parentheses around that to make it look a lot prettier. Kf, remember, is a given, and the Kf is right here. Copy that. And that is, again, just for water. But We'll put it inside the same text box. It'll be nicer. Parentheses, paste, parentheses. Oops, see what happened there? It does that to me sometimes. I don't know what's going on. I must click with my finger or something. So we have that in. And then finally, we need the number of ions, which is 2. So we have that molality in our calculator already. So that times negative 1.86 and then times 2. And so the change in the freezing point should be negative, because it's freezing point, 0.38, right? 0.38. And then let's put a 0 in front of that too to make it look nice. So 0.38. And then also the freezing point of water is 0. So 0 minus 0.038 is that same number. Now the next problem is the one you're going to do. So we set up just like this, except it's going to be the boiling point. And so make sure when you get to this last step, the boiling point is going to be plus 100. So whatever that number will be there for delta TB, add that to 100, and that should be your answer. All right, next problem. There's your problem you're going to do. And I'm going to do number 5. All right, a solution of Li freezes at 10 degrees Celsius. Freezes, so I meant freezing again, right? Maybe I should do number 6, so I do a boiling one. No, I'm just going to do this one. Okay, here we go. So let's look at that. So Li, so that ions there would be 2. I'm just going to fill in my givens. I'm going a little bit different order this time. It says it freezes at negative 10 degrees Celsius. Usually water freezes at 0, so that's a change in temperature of about 10 degrees Celsius. So let's put that in there for the freezing point is that. And that's going to be weird. Let's get that junk out of there. I don't know why it does that to me. And then also the change in the freezing point is going to be negative 10 also, which is a very big freezing point. Okay, let's see if I can get this cleaned up a little bit. So that's because it is water freezing. If this were boiling, it would be 100 degrees. Let's look at the next problem here. If it's 102.5 degrees, the boiling point is 102.5. The change in the boiling point is 2.5. Okay, enough said. We have that already. We're trying to find our M. So trying to find our M, we're going to put this into the equation, right? So we have everything set up. This time we're solving for M. And so I'm going to take negative 10 equals M, which I do not know, times KF, which is that negative 1.86. Oops, I put a parenthesis. I put a 9 in there, so there were parentheses. There we go. And then also our number of ions, which because it was Li, the ions are 2. Okay, so we're solving for M. Putting that into the old calculator. Oh, my calculator just shut her down here. Come on. Okay. Putting it into the calculator, we're going to do the first of all, you put the side opposite of what you're trying to solve for. So we're solving for M. So let's put in negative 10 first. So negative 10, and that's not minus 10, that's negative 10, divided by negative 1.86, and then divide by 2. Remember, we'll put it to the bottom of the fraction if it's on that same side. So we're moving those down and across the equal sign and to the bottom. And I get 2.7. I want to round that to 2.7. So my molality this case is 2.7. This problem is kind of the opposite of the one we just did. And this time we use the equation to solve for little m. Last time we used moles and kilograms to solve for little m and went the other way. The kilograms of water, there's 2.5 kilograms of water. So I'm going to plug that in, 2.5 kilograms of water. Finding the number of moles. Let's see what our equation says. It says little m equals moles divided by kilograms. Let's put our numbers in the right spots. This time we have little m. Little m is 2.7. we have kilograms, which is 2.5. We're solving for moles, so take the opposite side first. 2.7. I had it in the calculator, I should have just left it. 2.7 divided by 2.7 times 2.5, because 2.5 is on the bottom of the fraction on the same side as what we're trying to solve for, so we're going to move it to the other side and to the top, equals 6.75 moles. 6.75 moles. The molar mass of Li from the periodic table. So there's our molar mass. Li is 7 and Cl is 35. So 7 plus 35 equals 42. So the mass of that thing is 42 as a compound, 42. And then we're trying to find the number of grams we needed. So we're going to do a little factor label. I'm using shapes again. I'm using my straight line. This time they gave us moles. So let's put moles up top. So we're going to put in 6.75 moles on top. We have to cross out moles. So let's put, come on, let me type. Put 1 mole on the bottom. Oh, not mole 1. What happened there? 1 mole on the bottom, and then we're going to put that 42 grams that we found from the table on top. Do a little multiplying. 6.7 times 42. 6.75 equals, you needed 283.5 grams of lithium chloride. Hey, I'm going to leave that next problem to you. Remember, this is boiling point. Everything should work out the same except this first part here, which I've already talked about. Have a great day. I'm going out for a run right now, so beautifully snowy run, our favorite. And I will see you guys after the semester. Make sure you keep all your homework up to date and have a great afternoon.